All right, my dear sweet loved ones, welcome back to what is closing us down to the end of the year. That is so crazy to me to be able to say. We are almost at the end of the year. So, in celebration of today being National Star Wars Day, allow me to say, may the Force be with you. All right, so we're gonna dig right in. And I figured this is going to be a little easier to do it like we did last week just because it's going to be a little more explanatory where you guys can see each and every step of how I've worked something out. So our lesson today is obviously on something called sums and differences. When we're talking about sums and differences, we are talking about adding and subtracting, my dear friends. So with that being said, let's slide on over here to example 1. We're giving the square root of 32 plus 3 times the square root of 8 minus the square root of 18. All right, so you'll see all these different steps right here. As always, I feel like they do skip a couple steps. So guess what? I have worked every step out for you guys. Let me zoom here. We're trying to focus that. You can freeze frame it if you need to see what I did here. All right, so I took the square root of 32 here, factored it, got 16 times 2. Then I factored out my 16. I got 4 times 2. 4 is a perfect square, so I can bring the 4 outside the radical, but you have to bring the exponent also, which gives me 2 times the square root of 2. So 2 squared is 4, hence we get 4 squared. So let's go look at the next portion. We had 3 times the square root of 8. I factored out 8. I had 4. 4 is a perfect square. It's a perfect square of what? 2. So I can bring it out again. So that gave me 3 times 2 square root 2. 3 times 2 is what? It is 6. So far we got 4 times square root of 2. And we have 6 times the square root of 2. Same thing. I went over here, factored out my negative 18. I mainly factored out 18 by itself first and then brought my negative over. So the factor of 18 is 9 times 2. 3 is perfect square. And I did that so I can bring it outside. So I can bring 3, if you will, leaving my 2 here. And then I kept bringing my negative sign down. All right, so basically why I did this is because if you'll notice they all have something in common. Square root of 2, square root of 2, and square root of 2. Even though this is negative, they still share the square root of 2. Now what I did is I combined them. I took 4 plus 6 minus 3 times the square root of 2. And then when you add that, you get 10 minus 3, giving us 7 times the square root of 2 for our answer. All right, I want to let you guys look at B here. B is a little different because we got, you guys remember what we called the number inside our index? You guys remember that from last time? All right, this time we have an index of 3, but our concept still remains the same. We're looking for like terms so we can make combinations, if you will. I did the exact same thing here. I took what was given to me first. I went ahead and factored the 3x to the 4th. I broke it down into 3s because I wanted to match my index. Previously, we didn't have anything, so it's an understood, remember, square, so it's 2. And that's what we got everything to here. But here, everything's going to be, we want to try to break it down to a 3. So I broke x to the 4th to x to the 3, x to the 1st, all right? That way I can bring this out. I brought out my x, so I got x, index of 3, x. All right? And just so there's no confusion, this leaves once you bring this out. It doesn't cancel here, but you still bring your x over, leaving this x inside. Same concept. Let's go over here and look. What are we trying to do? Well, we still got our index of 3. So I'm wanting to break this down. Convenient for us, 2 times 2 times 2 gives us what? 8. we can break the 4 down the exact same way we did here. X to the third, x to the first. Bring it out, bring it out. We bring out our x. We bring out our 2, leaving x to the first inside our radical. So now we got to take and add like terms. So I'm going to take what I have here and what I have here. And I'll bring it out just a little bit so you guys can see. So when I add x and negative 2x, I get what? Negative 1x. So that gives us for our final answer. Negative 1x, index of 3, x in the radical. And I'll back it out just one more time here. Let me turn it sideways here. If you want to freeze frame it. All right. With that being said, let's skip on down to example 2. Example 2 is going to be the exact same concept. We're going to break these down here. I'm going to bring out what I've worked out. If you can see right here, we got, I don't know why that's kind of blurry. 72, 36, 98, and 9. Well, guess what I'm going to do? The same thing here. I am going to try and factor each and every one of those out. And we'll back and let you guys take a look at this for a second. All right. I factored my 72 out, as you can see here. Broke it down. 6 times 2 is 12 times 2. Make sure I haven't left out anything. One thing I do want to make sure you guys don't forget, like when I squared it over here, if you have a negative 1 inside your radical, remember, it's our imaginary, so it's I. All right. So we factor out 72. We go and factor out 36. And again, pause is needed. I factored out 98. This is negative on the outside, not on the inside, so there's not going to be a negative I. This one actually does have a negative on the inside, so it's going to be your negative 1 is going to be I. Now, I do want you to see how I broke it down, if you would. 98, you just factor 98. You're looking, since this doesn't have an index, it's an understood index of 2. What I'm saying is it's a square right here, right here, right here, and right here. We want to get everything, if we can, times into the square root, into the square of 2, if you will. 9 here, we know how to break 9 down. It's going to be what? 3 squared. But it's got to be negative 1 times 3 squared because it's negative 9. So it's going to be a negative 1 equals I. So bring this out and bring out your negative 1 with it. It's going to be 3i, negative 3i. So again, I'll back out so you can kind of see here. After I finish all that, what I do is I get like terms. As you can see, when I factor this out, I got 6 times square root of 2. Plus, when I factored this out, you'll notice I had an I because I had a negative 1 inside my radical. Factored out 98. It was negative, so don't forget your negative sign. And I factored out my 3. It had a negative 1 inside the radical, so I had to bring an I out with it. I added like terms. So again, let me back out if you want to pause this and kind of just see what's up. All right, let's go to example 3. 3 is going to be a little easier, I think you guys might. Here we're trying to break down, it says simplify 2 times 3 to the 16th plus 3 to the 16th. If you'll notice here, they've added a 2 and a 1. Why'd they do that? So you could add those together. There's no exponent attached to it at the moment. So you can add 3 and 1. Remember, this is not multiplication. You are adding like terms. So this is a term and this is a term, not multiply this times this. If anything, you're multiplying this times this. All right? So with that being said, if you realistically wanted to put that there, you would put a understood 1 right here for the 2 as an exponent and a 1 for the 1 as an exponent. That way when you added, because when you multiply right here, what do you do to exponents? You add them. So you would have 3, and since they're the same, you'd put your understood 1 here and add your exponents. So giving you 3 to the 17th. And also, I worked it out right here in case that didn't make sense for you, what I was just saying. You have 2, 3, and 3. And the only reason we added the 1 is as a placeholder, basically. So you could add like terms on this side and like terms on this side. I added 2 and 1 to get the 3. All right, this one didn't have an exponent of 16, so it had an exponent of 1. If it doesn't show an exponent higher than 1, it's understood 1. So I added 3 to the first and 3 to the 16th. So realistically, I'm sorry, that should say multiply. So it's a multiply, and you add your exponents. So that gives you 3 to the 17th. I'll back that out again so you can see. All right, let's check out example 4. Example 4, we're trying to do the exact same thing. One thing I want to focus on example 4 here is you have 5, no exponent, 4 to the exponent of 3, 3 and 2 the exponent of 7. What I'm going to want to do, and I'm going to bring my worksheet over so you can see, is I want to factor those out in order to get them, actually, brought the wrong paper over, to get them where you guys can see like terms, all right? So if you'll notice here, I took my 4 to the 3rd and brought it down. I factored, okay, I factored right here and got 2 to the 2nd to the 3rd. Why did I do that? Well, I'm glad you asked. Because 2 squared gave me what? 4. But now I can multiply exponents, and it gives me 2 to the 6th. So the reason I did that is because now I have 2 to the 7th. I can break 2 to the 7th down, and I can have 2 to the 1st and 2 to the 6th. Well, guess what? Now I have another like pair. Okay, when I say like pair is, you can't add 3 and 7, the exponent of 7. This is not 27. This is an exponent of 7. I'm sorry. So I had to make them common in order to do so. So I brought this down, my 4, right here. I went 2 squared, because 2 squared gives me 4, and I've still got my exponent of 3. But now I can multiply these and gives me 6. I can break the 2 to the 7th down and get a 6 and a 1. And then that allows me to add 5, 3, and 2. And now I can add 2 and 6. And so 5, 3, and 1. Is that what I had? Yeah. No, sorry. 5, 3, and 2 gives me 11. And 2. Oh, yeah. Sorry. Make sure I got the right ones here. Yeah. Okay. Sorry. Just want to make sure. All right. So after I've split, and I put over here too, just so you can see what I was talking about when I said split to get 2 to the 6th. I'm talking about this 2 to the 7th. Again, I broke it down right here. 2 to the 6th and 2 to the 1st. Because if you multiply these back together, what do you get? Your original, 2 to the 7th. So I've got 5 times 2, which is, 5 plus 6. I don't know why I'm struggling to talk. So basically what I'm saying is I'm adding these. Combining like terms. 5 and 6. Okay, gives me 11. These stay the same. 2 and 2. And you got 2 to the 6th. So allow me to back out so you can see what I'm talking about. After I split everything, I brought my original 5 down. My 2 to the 6th, which came from here. My 3 from here. 2 to the 7th broke down. 2 and 2. So I can multiply these because I got an exponent of 1. That's 2 to the 6th. It's just 6 to the 1st. And 5. I can add 5 and 6 and 2 and 2, 11 and 2. I'll back out so you can see. All right, now we can go to example 5. Example 5 is going to be a little more tedious, but the same concept. We're trying to break down things that are similar. The only thing that we got different here this time is we have what? An x and an exponent as opposed to just constants. But same concept. Bring this out where you guys can see. I take my original, which is here. I start looking for things that I can, because I want to make things like, okay? I'm looking for things that I can make like. And so it looks like for me that I'm going to be making things in a grouping like terms again. So 5, 4x, 2x, 3 to the 11th, and 3 to the 10th. Why do I have 3 to the 16th there? It should be 3 to the 10th. Sometimes I can't read my own writing. There we go, 3 to the 10th. I'm breaking this down because I want these to be in increments of 2. So just like I did previously, I can break this down, and guess what? It gives me 2 times 2. All right? So when I do so, I get 2x. Well, guess what? This one was 2x. So now I have a like term. So broke the 4 down. It gave me, because it's 4x, now it's 2 squared x. So that's 4x. And you do what to the exponents? You multiply those. So that's 2 to the... Yeah, so it's 2. That's going to be 2x. It matches here. Now what do I want to do? Well, I need to break this 11 down so I can have an exponent of 10. How can I do that? Well, I can take 3 to the 1st and 3 to the 10th. If you'll see, 3 to the 1st and 3 to the 10th. That way I can have like terms. All right? So now I've got everything broke down. I kind of just set them up where I can go back and group all of these. So I broke down this 4 to 2 squared. That way I can have 2x and 2x. I broke down the 3 to the 11th so I can have a 3 to the 10th. I broke that down 3 to the 1st and 3 to the 10th. Now, guys, all it is going back and adding up your like terms. So here, after you take your 3, your 2, bring your 2x to the 2x plus 1 plus 2 times 3 to the 10th. And I'll back out so you guys can see. I tried working out step by step for each of these. That way, hopefully it wouldn't be too confusing. And I know it probably isn't, again, as easy as it is being in class. But if you do have any questions, please, as I always stress, get in touch with me. I'll work them out, help you guys whatever you guys need. So you guys can FaceTime me. You guys have my phone number. Text me, FaceTime me. We can do a Facebook call. And again, I'll post these photos right here actually on the Facebook page also. All right, guys, that's the end of lesson 7.3. So I'll let you guys get at it. And if you need any help, holler at me.